Assalamu alaikum, everyone. I would like to share a question which I found. It's quite interesting. And if you ask me, if I refer to the scheme answer given, the way they did was very strange to me because, well, if a student doesn't know that particular approach, then how are they supposed to know? Therefore, I would like to show my part of the work on how to solve this particular integral. Okay, so I believe that the integral given is the integral of 1 plus 2 x raised to the power of 2 times with e raised to the power of x power 2. So the way we want to solve this is firstly we expand it. Expand term by term. We will obtain the following. So it will be e raised to the power of x squared plus 2x squared times e raised to the power of x squared dx. And now we have to separate integrand so that I could show you on much clearer, a bit clearer. So here we have the first term, which is e to the power of x squared dx plus 2 times x squared times e to the power of x squared dx. Now, just so you know that this is from this integral, okay? Now, what I'm going to do is by focusing only one term, which is this term. And the way we want to focus is that we will be using the integration by part, one of the techniques of integration. Therefore, the resulting integral will lead you to the final answer, which is very, very nice. Alright, so I'll do it here by focusing on the first term. In other words, I am only focusing on e to the power of x squared. So, e to the power of x squared. Now, the way we want to solve this integral is that by using integration by parts. And I'll be choosing dv. Dv as in dx. So here will be dv is equal to dx. And then this implies that when we integrate this, we will obtain v is equal to x. Now how about our u? So our u will be e to the power of x squared. And when we take the first derivative, we will obtain du is equal to 2x times with e to the power of x squared. Now, let's recall a bit about the formula for the integration by part technique. So, u dv, we will obtain uv minus with the integral of v du. Okay, so by substitute the respective terms into the formula given, then the resulting integral for e raised to the power of x squared dx would be x times e to the power of x squared minus the integral of v du, 2 times x squared times e to the power of x squared dx. Now, this is the resulting integral. Now let's go back to our previous lines. As you can see, this integral is similar to this integral as we mentioned before. So the way we want to proceed is that we substitute the resulting integral, which is this one, into our previous line. Then we will have this result: x times e to the power of x squared minus 2 times x squared e to the power of x squared dx plus with 2x squared e to the power of x squared dx. Now, since both of these terms are alike, they only differ by a constant if they have different constants, but we are dealing with a indefinite integral, so at the end there will be a constant. It's just that we do not know what is the constant. Either it could be 0, 2, that's why we call it as a constant. So this could be simplified further. Therefore, it will be okay. If I so it will be x times e to the power of x squared. Then we create a conclusion. Therefore, the integral on which 1 plus 2x squared times e to the power of x squared dx is equal to, sorry, I forgot my plus e, x times e to the power of x squared plus c. So for me, it's a really nice question because the scheme answer is very different. They assume that we know the product rule, since if we take the derivative of this product rule, we should obtain the same result. And they assume that we could see that by rearranging the terms. But as for me, as a student who's been learning more integrals than ever, I believe that this approach on solving the integral is better. It's just that you want to determine which one is which. You want to use the first term or second term, but for this case, it's the first term. Okay, I think that's about it. If there is any errors I created, please do let me know, right? And I'll see you later.